Hi, welcome to the Calculus 1 lecture series. And we are in the unit number 2. In this unit, we talk about the derivatives. And this is our lecture number 11. And we're going to talk about the chain rule. We will divide this lecture into 2 videos. And so break the lecture a little bit shorter. Okay, the chain rule probably is one of the most important rule in the calculus. And when we try to do the derivative. Okay, so let's go to our worksheets and take a look what is this chain rule about, okay? So you know that if you kind of refresh your memory, so before we even define what is a chain rule, let's do a kind of a very brief refresh. Okay, so far we have learned some several very useful formulas, right? So for example, we talk about the power rules here. So for example, we said f of x is equal to the xn. And then we know the powers rule tell us, we say, hey, the f prime x is equal to what? You move the power down, then the x to n minus 1s, right? So this is one of the very, very common rules we use. And then also, then after that, we introduce like 6 trig functions, correct? So for example, we say f of x equal to the sine x, then you will say f prime x equal to the cosine x, right? Or if you said f of x is equal to the, like let's say tangent x here, and then we, from our previous lecture, we know that then the f prime x, the tangent x, the derivative will be the secant square x. Or, we learned the derivative for the exponential. So if the f of x is equal to the ex, then we say the f prime x is equal to the ex, just itself. That's pretty cool, right? So if you look at all this rule, then you notice here is all x here. So like here, this is f of x to the x to the nth power. This is f of sine x, just x here. This is f of x equal to the tangent x here, right? Then this is f of x equal to the ex. So we're all dealing with a simple value x here. So now we come into the province here. We say, how about if I have a functions, if f of x is equal to, let's say here is x plus 1, all right? So if we said, let's say this is, let's give a little bit more complicated here. So let's say here, if we have like 3x squared plus 1 and to the 5th power, then I want to find f prime x. How do I do that? So as you can see in here, the first things you see, oh, this is kind of like a power rules, right? Because I have this exponents here, it's phi. But then the province here is, that the formula we have, if we use the f prime x equal to the n times x of n minus 1, and has to be x. But in here, we have 3x squared. So it's not just x anymore. So how do we do this? Right, so I cannot just say that, hey, f prime x is just the phi, use the power rule, 3x squared plus 1 to the 4th. Okay, I cannot do that because this formula, the formula we learned previously, is only have the value of x. Okay, so like in here, of course, you can say, I can FOIL it, right? So I can FOIL the 3x squared plus 1 to the 5th power. Yes, you can do that, but it might take you at least maybe 20 minutes to just FOIL this, like the 5th power. So if I have like a 10th power, it might take forever to just FOIL that out, right? So this is where the chain rule will come in. So if you take a look at this f of x, so if in here, if you break it, you said, so if I say that I have two functions. I said gx here is x to the fifth, right? Now I definitely know how to take the derivative of x to the fifth. Let's match my basic, let's match my basic power rule function. Then I will say that, hey, I can define the h of x. So the h of x, I can define it is to be the 3x squared plus 1. So for both of this, you can take the derivative by using my power rule. But then you might ask why you want to define these two. So now if you take a look for these two functions, okay? So if I do the composite function, so I said the g to the hx, well, I think that in the algebra, you use these notations, right? So you use the g composite to the h here, right? So then that means you put whatever the h you replace in the g's, right? So this is what we said is a g to the hx. So that's what is the chain rule about. So the chain rule tell you, you can do the composite functions to the two functions, and then you give it the functions here. And then if I want to take the derivative, how do I take the derivative? So this is what is our chain rule. So let's write it, okay? So here I said y. So if y is the composite function for the f and g, so we say y is f composed g. So this is f of gx here. All right. Then when I want to take the derivative, so the derivative of the y prime will just be equal to you take the derivative of these composed functions, the whole thing's here. You take the derivative. So remember, you take a look at these examples, right? So both this function and this functions, right? So the g and x, they both, you can use the basic formula to do that. So now that's what is our chain rules here. It will be, so that means it will be, you take the function f prime x first, right? Then you still have the composite function for the gx, then times g prime x here, okay? So that is what is our chain rules definition. So some people also say the chain rule kind of like the peeling, the onions, right? So like one layer, two layers. So you need to recognize where is your first layer, like what is the gx, what is h of x, how do you peel that? So for each layer, you can use your basic and fundamental formula to do that. All right, so we're going to do some several examples, and I'm going to show you what I mean, the peeling the onions, right? So what is the one layer, what is the next layers, right? Okay, so now let's take a look at some very basic ones here. So these ones here, let's say the h of x is equal to the f of the gx. So that means f composed g. All right, so then they give us those values. I want to find the h prime 4. Okay, so first is I will find the h prime x, right? So remember, because this is composed of the f and then the g. So what I need to do is here, I need to take the derivative of f prime. Then I still have a gx, right? And then times g prime x. And now it asks us f prime, h prime 4. So I will apply the x equal to 4. So this is 4. So now let's take a look at what I have. This is f prime g4, then g prime 4. Okay, so now let's see we can find the values here. Okay, g prime 4 is here. Oh, hey, g prime 4 is 5. Okay, so this is 5. Okay, g4. Okay, g4. Oh, g4 is here, right? So inside here, g4 is 7, right? So G4 is 7. And then, so what is this outer layer? This is F prime. How many? F prime 7. Then you will see, oh, F prime 7 is here, right? So that means the whole distance equal to what? The whole distance equal to 3. So what is the final answers here? The final answer is what? It's 15. Okay. And now it said problem number 2, it said, does the dH dt is equal to dH dx du dx over du, du over dv, dv over dt. Okay, so this is, this one does make sense. If you just kind of like treat it as the algebra, all right? Of course, this is not real algebra. So, but if you treat it as the algebra, then you see here the dx and the dx cancel, right? Du and the du cancel, and the dv and the dv cancel. Yes, you have dh over dt. But what is this means here? Of course, this is from the algebra point of view. Is kind of like you said you can cancel, but in fact, when you take the derivative, you cannot really cancel the du, dx, those things. But what is this one tell you? They said, okay, so if I said y, okay, it's a function of h, right? So because here, take a look here, they said this is a dh dt here. That means this one's here is what? Is ht, is the final value, is a, so, y is a function of t here, right? So that's why when you find y prime, that will be equal to the dh dt, all right? But what is all these things in between? So basically, this one will tell you, say, hey, h is here, I can have, so this really is a composite function for many functions here. So the first layer is h. Then I can have a function x. Then function x is a value u. And the u is a function of the v, right? And the v is a function of the t's here. So let me see, 1, 2, 3, 4, 1, okay. So that's why you have how many functions you are composite? You have x, u, v, and the h, right? So this is a kind of a very complicated composite function, but that's the same ideas, right? So you take the derivative for the first one, and then you'll be able to kind of, so this is a take the derivative. So let's remove these things, and then let's see what that means here, right? So the dh dx, that's your first layer derivative. Then dx du, that's your second layer derivative. Then the du dv is third layer. Then last layer is dv dt here. Okay, so this is a pretty interesting, right? Means in this composite function, how many I have? I have 4 of them, right? But the idea is the same. Okay, so now let's take a look at some example and see how do I get the derivative by using the chain rules here. Okay, so like we talk about, now when we look at this, the first things we need to know, where is my first layer? And where is my second layer? Where is my third layer, right? So for these ones here, the problem here, this is y equal to the x cubed plus 6x, the square root. So if you rewrite these ones here, this is x cubed plus 6x. What is the square root? Square root is 1/2. Then you immediately see, you say, oh, wow, the 1/2, that is kind of like a power rules, right? And then I have something inside here. So like in here, then you say, okay, I think I know how to do that now. So the first layers here, right? So what is the, okay, so what is the first layer? The first layer will be the x cubed plus 6x to the 1/2. So the first layer is what? Is this exponents, is the power rule. Then my second layer will be x cubed plus 6x here. Okay, so if you use the power rule, so what is the derivative of here? You will say it's 1/2, right? Then whatever inside this parentheses, x cubed plus 6x. So 1/2, what is the top here? Is 1/2 minus 1, so it's negative 1/2, right? So this is your first layer, right? So you do the first layer, you use the power rule to take the derivative. And now you have this, the second layers, right? Okay, so the second layer now, you also be able to just use the power rule, take the derivative. So what is here? X cubed will be what? 3x squared plus what? 6x, right? So this is your second layer. So after you do that, and then my final answers will be what? Will just be you multiply these twos here. Okay, so let's try to write it down. My answers is y prime is equal to what? So this is 1/2. This is the x squared. So I can really put the buttons, right? Because it's negative 1/2. So it's x cubed plus 6x, the square roots on the bottom. Now, what is the top here? The top, will be 3x squared plus what? 6x, right? So the top will just be 3x squared plus 6x. And that is our derivative. Okay, so now let's take a look. My second problem is here. And I'm going to use the same color. The first layer, I'm going to color the yellow, all right? Second layer, blue. If we have a third layer, then I'm going to, color the different colors so we can get the idea. Okay, so for this one here, so you see here, this is the second x squared. So you immediately think about, oh, in the trig function, I did learn the trig formula for the second x, right? So, so I know my first layer of the onion is the second, right? So that's why you write here. So this is the second. Then whatever is inside here. So that is your first layer, okay? Now, after you get to the second, what is your second layers here? Your second layer is x squared. Okay, so that's what you get your x squared here. Okay, so that is your second layers here. Okay, that's how do you put it inside the first layer, right? So now let's take a look. How do I take the derivative? So remember, my first layer is the second. So what is my derivative for second here? Will be the second, whatever is inside is x squared and the tangent x squared, right? Because the second x is the second times tangent, right? Now, after that, right? So here, this is basically the second is the second times the tangents, right? And then now the second layer here is x squared. So what is the derivative of x squared? It's 2x, right? That's good, right? So now what is the final answer? You multiply these two, all right? So let's try to write down my final answers here. Y primes will be what? Will be the second x squared, tangent x squared, the whole thing, so you have what? 2x. Or if you want to look at write it in a better way, so this will be the 2x second x squared, tangent x squared. All right, so that will be the final answers here. Okay, now let's take a look at part C here. So the part C, this is the second x squared, right? So second x squared. So immediately you see, oh, I have squares here. So this is the power rule. So the 2, the power will be my first, what? First layer. So what is my second layer here? My second layer will be second x here. Okay, so now let's try to write it and to see we know how to take the derivative here. So the first layer is the second x, right? Let's put it this way, is a square. So it doesn't matter you put the square here or outside. Probably for the outside is easier to understand here. Then the second layer is second x, right? So the first layer is 2. and the second layer is here. That's why I say I'm color coding that, right? So the first layer I used the yellow, and the second layer I used the blue. See here. Okay, now let's take a look at the derivative. So the first layer is exponents, right? So I use power rule, so it's a 2. So whatever is in here, it's a second x. So what is a 2 minus 1? Is 1. All right? So now that's how do I get the first layer? I use the power rule, right? Then the second layer is here, second x, one more time. What is the second x? Is the second x tangent x, right? So I'm using the second x derivative formula. Okay, now I got both my layers. So what is my result here? Your result will be multiplying them together. So here this will be y prime will be the 2 second x tangent x. If you want to combine a little bit, you can say this is 2 second square x times tangent x here. All right, so don't forget. So if you see the square in here, that means this is the second x square, right? So this is the second x square. Like the part B, we have the square on the x. That means it's the second function, but it was x squared. All right. All right. So now this one is a little bit kind of the complicated here, right? So the first one's here, I see here, this is a cosine cube x squared. So if I rewrite this, maybe it will help me to see. So this is a cosine x squared to the what? To the third power, right? That's what we say, the power you can write here, take it out. Okay, so now for here, what is my first layer? I see the power rule. So this is my first layer. After you remove the first layer, inside is a cosine x squared. Oh, cosine x squared. So what is my second layer here? My second layer is cosine, correct? Now, what is my last layers here? My last third layer is x squared. So this is have 3 function, composite functions, right? So, okay, now let's try to see if we can do it. So it should be pretty straightforward, right? So here, this is a cosine x squared to the cube, right? So remember, this is my first layer. So how do I take the derivative? It will be 3 cosine x squared. So whatever inside, I'm not changing, right? So it's 3 minus 1 is 2. So this is 3, this is 2. Okay, now remember my second layer. What is my second layer? My second layer is cosine x squared, right? So here, remember this is my cosine. So what is the derivative for the cosine? Is a negative sign, right? But the x squared is still here. I'm just looking for the functions, right? So it's a cosine. Okay, so now what is the, so here, so the cosine will give you negative signs, right? That's what is the derivative, the second derivative. Now, what is the last layers here? Last layer is x squared. And what is the derivative of x squared is 2x, right? So that's what is my third layer and the third layer derivative. Now we do the same. So the final answer will just be times and the times, right? Okay, so let's rewrite it. So the y prime will just be equal to 3 times the cosine x squared, the square, negative sine x squared, and 2x, right? If you want to rearrange and combine it a little bit, it will be equal to negative 6, right? Move the x to the front. If you want, you can move the sine x squared here. Then here, this is cosine x squared to the square terms, right? So you can write that. Okay, now, next one's here. Okay, so the next one's here. This is y equal to the sine 2x cosine x. So first things you say, oh, these two, right? I have a function here, I have a function here. So what I need to do here, I need to use what rule? I need to use the product rule first, right? So I say y prime. All right, so product rule, you take the derivative of the first one, sine 2x. You need to take the derivative times the hold the second one. Then plus sine 2x, you're not moving, and then you take the derivative of the cosine 3x here, right? Take the derivative. Okay, so now let's take a look. This one, all right? Let's take a look at this one. Oh, I shouldn't use this color. That kind of maybe be confused. All right. All right, so this is the sine 2x. You take the derivative. Okay, by the product rule, so let me see which color. I did not use this color, all right? So let's take a look. What is this one? What is this one, right? Okay, so let's see here, sine 2x. So what is the first layer for the sine 2x? Is sine, right? Correct, that's my first layer. So what is my second layers here? Is 2x, correct? Okay, now I can start to take the derivative. So what is the sine? Sine is cosine, right? Now what is the 2x? Is 2. Do you get that? All right, so then the first layer, because it's the sine, so sine take the derivative is cosine. So this term will be 2 times cosine 2x. Let's do this term also. So this term cosine 3x. So obviously, what is my first layer? It's a cosine 3x, right? So it's my what? It's a cosine, is my first layer. What is my second layer? 3x, correct? All right, okay, so now you take the derivative of your first layer. So you take derivative of cosine, you will get a sine. Right now, whatever inside you put here. So that's why the cosine corresponding to negative sine. So what is the 3x you take derivative? It's a 3, right? So that's the second layer derivative. Then do the same. What you need to do, multiply them. Okay, so now let's try to put it back to whatever we have. Okay, so the first one, this is a 2 cosine 2x. So it's a 2 cosine 2x times cosine 3x plus sine 2x, right, times 3 times negative sine 3x here. Or you can rearrange this a little bit. So this is 2 cosine 2x, cosine 3x, 3 and the negative 1. So it's minus 3 sine 2x, sine 3x. All right, so that is, so this one combined what we learned before. So what combined what we learned before? The product rules, right? So don't forget when you know, product to function, this is what we call this the product rule. All right. Okay, so let's take a look at this ones here. So this one is y equal to the sine secant. Oh, so you say this one, I think I can spot very fast. So what is my first layer? My first layer is what? My first layer is a sine. After you find the sine, so what is your second layer? The second layer is secant x, right? So this is my secant x. Now I can take the derivative. Okay, so sine, one more time. What is the sine's derivative? Is a cosine. Now whatever you have left, right? So remember this is the derivative corresponding to the first layer. Okay, now what is the second x? Secant x you times the derivative will be secant x tangent x, right? And this is the derivative for the second layer. Now, what you can do, you multiply. Okay, so now let's try to write it down, my final answer. So y prime is equal to the cosine secant x times secant x tangent x here, right? So be careful. This secant x is inside the cosine. So probably if you want to avoid confusions, you can say this is a secant x tangent x cosine secant x here. All right, that's what is the chain rule about. It's pretty, I think it's not too bad, right? So you look the function. So remember our kind of a basic function, or sometimes you can call the parent functions, right? So we only have a few, right? We have a power rule, xn, then we have the six trig function, we have ex. That's it. Anything deviate from the x, we will need to use the chain rule, right? Okay, let's do one application problem here. Right, so, I'm sorry, we have two more problems here. Okay, let's try to do here. Okay, so this is the sine tangent x squared plus 1 to the 4. So for this ones here, first things I spot is, I have my tangent functions, right? Okay, so now let's see how do we take the derivative of these ones here. So what is your first layer? Your first layer is the tangent. Right, so this is your tangent function. Okay, after that, what is your second layer? What are you left for that? Your left is x squared plus 1 to the 4. Oh, I got the power rules, right? So what is your second layer? Is the power rule. Correct? Okay, now after you remove that second layer, what is the last things that I have here? X squared plus 1. Right? So you have x squared plus 1. This will be your third layer. Okay, now let's try. Okay, let's try to see. So what is the tangent derivative? It will be secant squared, right? Then whatever inside, you keep it. Okay, so if you color that, so the tangent derivative is secant. Okay, now for this one, we say the second layer is a power. So what do you do here? So you take the power down. So it's 4 times x squared plus 1. What is here? 3, right? So this is you use the power rule, right? You see the color, color coding here. Then the last one is x squared plus 1. What is here? Is 2x here. Correct? All right. Okay, after that, then what do? We multiply them together, right? So if you multiply them together, so for this one here, I have y prime. So if you combine a little bit, so 4 times 2 is 8. So it will be the ax x squared plus 1 to the third, then the secant square, x squared plus 1 to the 4th. Or you can rearrange the order, doesn't matter, right? So I just like to put it this way, okay? So now let's take a look at the last one. This is y equal to x squared minus 1 to the 4th. Of course, I can use the quotient rule, but quotient rule typically is pretty complicated. Well, let's see here. Let's see anything good. If I rewrite this is x squared minus 1. Because the 4 is in the bottom, so I would say this is a negative 4. Then you see here, you immediately spot what is your first layers here? It's a power rule, right? So instead of use the quotient rule, become very complicated. Okay, so now we can do that. So this is x squared minus 1 to the negative 4. And the negative 4, that is your first layer, right? So it's the power rule. So after you mark this off, what is left is x squared minus 1. That is your second layer. Okay, now you take the derivative. So how do you take the derivative of the power rule? You move the power down, so it's a negative 4. So whatever's here, you remaining. So negative 4, then the n minus 1 is negative 4 minus 1. So what is here? It's a negative 5, right? So whatever you got in here and in here is from the power rule on the first layer. Now the second layer, x squared minus 1, what is that? It's a 2x. That's pretty good, right? So it's 2x. Now what I need to do, multiplies, right? So after you multiply, so I can say y prime 2 times 4 negative 8 and x squared minus 1 to the negative fifth, or you can just say negative 8x squared minus 1 to the fifth power. All right, okay. So now let's take a look at this application problem. So the application, they tell you the temperature at noon at the top of the mountain Arthur is approximately this functions here on the degree C. So find the rate of the change on January the 15th here, okay? So I will set here, okay, I will say this is my temperature on the day, on the each day here, right? So I would let this temperature is 50 plus 30 sine, and this is pi x minus 200 and 180. So I'm looking for, because the rate of the change, right? Take the derivative. So 50, what is the 50th derivative? This is what? This is a constant, right? So this constant, so will give you what? Will give you 0. And the plus and the 30, you're going to times what? The derivative of these numbers here, right? Okay, so now let's see how do we times the derivative of this number. This is like a sine function, but it's pretty complicated inside. So I know immediately, I see this is a sine function. So this is my first layer. Okay, so let's put it here. So this is the sine 180 pi x minus 200. All right, so then the second layer is 100 pi x minus 200 here, right? Okay, so as we see, this is my first layer. So what is my second layer? This is my second layer, right? Okay, so now let's take the derivatives here. So the derivative sine is what? It's a cosine. Then don't worry, write it down, whatever is inside the layer. So this is 180. Okay, so the second layer is 100 pi x minus 200 divided by 180. So what is the derivative? X is x to the first power, right? So it will be pi over what? 180. So this is here, then you times it, right? So you times it. So this is here, after you take the derivative, what is will be here? It will be pi, 30 pi over 180. Then I have a cosine. This is a pi x minus 200 and 180, right? That will be, this is the derivative, the one that I used to read, right? Now, in here, they find the day 15. So I'm looking for P prime is what? 15. So it will just be 30 pi 180, then cosine pi. This will be 15 minus 200 and 180. All right, then you can plug into the calculator and you will get this is about the negative 0.52 degrees C per day on that day, right? So that is the, you know, that is what we call the, the chain rule applications, right? So when you do the chain rule, so I guess the challenge is you need to be able to identify where is the first layer, where is the second layer, right? So how to peel the onion off, right? So you can peel that off and then you can take the derivative. That's why, when here, I always color coding, right? So for example, the sine, so the derivative of the sine become cosine. So whatever inside, I'm not doing that. Then here, this is the same things, right? So whatever the second layer, you take the derivative. That's what it is. All right, so we're going to, this is our first video. We're going to stop in here. And in our next video, we're going to talk a chain rule for very special functions here. All right, Okay, so nice talk to you. Have a good day. See you. Okay, bye.